Just a few years ago, teaching a computer to imagine 3 dimensions sounded like complete science fiction. Today, anyone with curiosity, a browser, and the right tools can experiment with this exact idea. Hello, my name is Paulo Sesta, and I built my own diffusion model that generates both 3D models and 2D images from purely text. This project combines Stable Diffusion version 1.5, which turns text prompts into images, and SHAP-E, a neural network that creates 3D objects from text descriptions. Diffusion models work by learning to reverse noise. During training, images or objects are gradually destroyed with random noise until they become unrecognizable. The model learns how to reverse that process. Using Google Colab allows the program to run on a GPU, making the project more accessible since all you need is to have a browser to run the program. In Google Colab, code is divided into sections called cells, allowing each part of the code to be ran independently to facilitate better workflow and step-by-step execution of the code. As the cell loads in, I'll explain what's happening. In the first cell, we install libraries the project needs to run. These packages handle the image generation, 3D model creation, and GPU acceleration. When the cell runs, Python downloads these tools from the internet so the program can use them later. Yeah, so once everything is installed, the next cell imports those libraries into the Python environment. Importing allows the notebook to actually use the tools that we just installed. Yeah, so after that, the next cell checks whether GPU is even available. If one is detected, then the program prints the GPU name and how much memory is available. Once we're done with that part, we get to cell 4, which creates the output function that converts generated files into clickable download buttons, allowing images and 3D models to be instantly saved from the notebook. And now we're on cell 5 and 6, where the real downloading process occurs. As cell 5 is responsible for the image generation portion, and cell 6 is responsible for the model generation. These cells will take a bit longer to run, so for the time being, I'll dive deeper into the purpose of this project. Diffusion models can generate many types of media using the same core processes. Rather than memorizing images or 3D objects, the model learns the statistical patterns that makes the things look the way they do. Most people interact with this technology through polished AI tools, but those tools often hide how the systems actually work. This project was created to make that process more accessible. Instead of only using finished AI applications, anyone can open this notebook, run the code, and explore how diffusion models transform noise into images in 3D objects step by step. Yeah, so cell 7 defines the function used to generate the images from text. Users can also adjust the settings like image resolution, number of generation steps, and randomness to control the output. Cell 8 is similar in the sense that it defines the function that creates the 3D models. The generated models can be viewed interactively, meaning they can be seen without having to directly download them. The files can be exported as either a OBJ or a PLY file that can be opened in software such as Blender or Unity. This cell generates the main interface for the generator. The notebook enters a loop that asks the user whether they want to generate a 2D image or a 3D model. After the user chooses a mode, they simply enter a description of what they want to create. For this example, we will create a singular 2D image with a description of something mystical with high quality settings. As you can see, we created the mystical creature I was talking about. And above, we can see the prompt that I used. By clicking the download button, I can get the PNG download of the image. Now, this time around, let's try something more difficult. This time, I want to generate two super high quality images of a futuristic city. Since I'm creating two different images, I can choose which one I'm going to download instead. This go around is taking much longer, since I chose to create two images that took 350 steps each compared to the previous 50 steps for the singular image I did before. Yeah, so I like the image on the right better, so I can choose to only download that one. Now I'm going to do the same process I did with 2D images for the 3D models. I chose to just create a chair with high quality. Now that is ready, I can download the OBJ model and download the PNG image of the texture. This is what the model looks like imported into Blender with its texture. Now we're going to give it a more complex topic of generating a 3D model of a computer. Now we're going to do the same process of downloading the OBJ and the PNG and uploading it to Blender. This is what the computer looks like imported into Blender with the PNG texture. The results aren't perfect. It won't match the commercial tools like Midjourney. But that wasn't the point. The goal was to show that the core technology behind those systems can be explored and understood by anyone willing to experiment with it. What's so exciting is what it means for the future. Tools that once required labs and expensive hardware are becoming accessible to students, developers, and creators. As generative AI evolves, models will likely not just be for images or 3D objects, but entire virtual environments and simulations from text. Projects like these are a small step towards the future. The more people understand these systems, the more innovation becomes possible. Thank you for watching. If you want to try out the generator yourself, the full project and the code will be linked in the description. Thank you.